Section 4.2, expected value. The expected value is the average gain or loss of an event if the procedure is repeated many times. And in order to figure out the expected value, what you want to do is figure out the probability of event 1 and multiply that by the value of event 1 and continue on. The probability of event 2 times the value plus. And if there's potentially 3 unique events, you could stop here. Oftentimes you'll find that there's just 2. For instance, suppose someone offers you 10-to-1 odds that you will not get 3 heads when you toss a coin 3 times. That is, you'll lose $1 if you fail, and you'll win $10 if you succeed. Is that a good bet for you? What is the expected value of the bet? So the expected value of the bet would be the probability of, I'm going to say the first event is the probability of winning, and the value of winning. So how much are you going to win if you won? Plus the probability of losing and the value of losing. Probability of winning, there was a 1 out of 8 chance of getting 3 heads in a row. And what are we going to win? We're going to win $10. What's the probability of losing? 7 out of 8. How much will we lose? $1. I'm going to enter the losing $1 as a negative, or $1.25, and subtract from that 7/8. So the expected value is 37.5 cents. So should you play this game? Yeah, you should. And the reason why is it is a positive number. So because it's positive, we're going to make more money than we would lose. And so I'm going to also explain this using a visual. So you had head, head, head as the 1 out of the 8 possibilities, and I'm going to just draw out every single possibility real quick. All right, so here's all 8 possibilities. This is the one time that you made $10, and then you lost $1, you lost $1, and so forth. So I've written out every single possible combination of heads and tails that we've seen in tree diagrams. We've made this list many times in this course. So head, 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 you'd won $10, and then you lost $1, you lost $1. You lost $1 7 times, and you won $10 once. So you won $3 over 8 games. It kind of sounds like I'm saying math right there, or an equation. $3 over 8 games, or $3 over 8 games. And what is 3 over 8? Why, it is that same 37 cents, 37.5 cents that we're making per game. The method to the left is the equation, and the method to the right is more of a you just understanding the concept. You can do either one. You can draw out every single possibility and figure out how much money you're ahead or behind by, or you can use the equation. I'm going to leave example 4 as a bonus question. It's a bit harder than the questions that you'll see on my open math. I will do example 5. A roulette wheel has 18 black numbers, 18 red numbers, and the numbers 0 and 00 in green. Well, first thing I want to figure out is how many numbers total is that? All right, so we have 38 spots. Some of them are black, some of them are red, 2 of them are green. In roulette, betting on red is a 1-to-1 bet. That is, if you win, you gain the amount that you bet. If you lose the money that you bet. What is the expected value of a $10 bet on red? We'll do expected value. Probability of red, value of red, plus the probability of not red, and then the value of not red. Probability of red, 18 reds out of 38 spots. Value, we would win $10. Plus the probability of not red. Don't forget those green spots. So there's 20 that are not red out of the 38. And if we landed on one of those, we would lose $10. So remember to make that one a negative. 18 divided by 38 times 10 plus 20 divided by 38 times negative 10. And for this one, we're going to have a negative, and because it's money, I'm going to round to the nearest cent. We're going to lose about 53 cents every spin. So the expected value is 53 cents. That doesn't mean that you're going to lose 53 cents each time. It's saying that on average, you're losing 53 cents. Even though you're losing it in tens, you're either getting 10 or you're losing 10. If you were to spread out all of your experiences, you would find that you lost 53 cents each time, even though in reality it was coming to you in tens and leaving you in tens. And the reason why you're losing money is because there were 20 spaces for not red compared to the 18. Those two green spaces are called the house edge. They're the thing that gives the house just that little bit of money that it needs to keep the lights on. It's not a little bit of money. In fact, it's a lot of money, you will find. So these next few questions are about house edge. Casinos make money because the expected value in every game is negative for the players, positive for them. The house edge is the amount the casino can expect to earn per dollar that is bet. Averaged over all games and all bets being played, a particular casino has a house edge of 8 cents per dollar gambled. If a total of 150 million is bet in the casino over the course of the year, what is the casino's profit? So this isn't terribly difficult. There's no crazy formula for it. Every dollar bet is making 8 cents for the casino. So let's take the 150 million and simply multiply it by 8 cents. And that will be how much the casino made. The casino made $12 million. A casino card game takes $4 bets. Players have a 30% chance of winning, in which case they win back their bet plus $8, and they have a 70% chance of losing their bet. What is the house edge? And so what we're figuring out here is how much are you winning or losing on average every time you play this game, down to the dollar, okay? So let's set up expected value. Expected value of this is the chance of winning, probability of winning, and the value. And then we'll have the probability of losing and the value. Probability of winning is 30%. What do you win? You win $8. What's the chance of losing? 70%. What do you lose? You lost your $4 bet. So where are we? Oh yeah, don't forget the negative because you lost that $4. All right, so you're losing 40 cents per game. How much are you losing per dollar gambled? It cost you $4 and you lost 40 cents. So we'll take the 40 cents and we'll divide that by the $4 bet. And you'll find that your house edge is 10 cents. That every dollar that was bet on this game made the casino 10 cents, which is pretty good, especially since the first example, they were only making 8 cents per dollar gambled. So this card game is making the casino a little bit more than average. You should try C on your own. It's about blackjack. This is one of our last topics, the gambler's fallacy. It is the mistaken belief that a streak of bad luck makes a person due for a streak of good luck. And in chapter 1, we were talking about all sorts of fallacies that existed, like the straw person argument. This fallacy is very specific to gambling or to luck. For instance, in example 7, suppose you flipped a coin 5 times and each time it lands as heads. Would you expect the next flip to be tails? Why or why not? And so what I would say here is that the coin has no memory, and so it is as likely to be heads or tails in the next coin flip. It didn't matter that its past was filled with heads. It still has a 50-50 chance each time. The overall experience has been weird, but it doesn't mean that the coin is somehow due, or any more due than it was 2 coin flips ago. Each time it has a 50-50 chance. Those chances don't change based on its past. All right, so you go ahead and give me your thoughts on example 8 and 9, and that is where we will end. Okay, I will see you all later.